All right. So today we are going to continue from data structures. So this is data structure part 2. And today we are going to be finishing up by understanding what set is and what dictionary is. Okay. So let's write on. Please, as usual, keep your questions, write them down. And there will be room for questions at the end of the class. Attendance will be dropped 1 hour into class. So please don't log out. Thank you. All right, so sets. Now, last class we looked about we introduced the data structure to you guys, and we looked at lists and tuples. We learned the differences between them and the applications. So today we are going to cover the remaining two, which are sets and dictionary. Okay. Now, what is set? Set is a collection of values. Sets are unordered. And most importantly, sets do not accept duplicates. You can combine it and say set is an unordered collection of values without duplicates. All right. Now, when you are declaring a set for a list and tuple, a list is you identify a list with a square bracket, you identify a tuple with a round bracket, or you identify a set and a dictionary with a coily bracket, coily brace. The brackets for sets and the bracket for dictionary are the same, but they are different methods of operation. So for sets, you identify it with a coily bracket. All right. Now, when you are declaring a set, when you declare a set without values like this, empty set, it is seen as a dictionary because it uses the same structure as a dictionary. A dictionary, when it's empty, is like this. A set when is empty like this, so it's seen as a dictionary. But there's a difference to sets and dictionary. All right. So if we run this now, you type to check for the data type, it will show us as a dict instead of a set. Okay. Now, how do you identify a set that is different? A set has singular values just like list and tuple. A dictionary does not have singular value. Okay. When we get a dictionary as we digress. But note that when you declare it as empty, it is seen as a dictionary. But when you put values into it, that's when it changes. Okay. The same way we put values in list and tuple is the same way you put values in set. You separate them with comma. All right, you separate them with comma. So sets can carry different data types, integers, floats, boolean, strings. Okay. Now let's run this and you see the output. For this one as empty is a dictionary, but this next one to put values, it is seen as a set because these are singular values. But because of the curly brace, is a set. Okay. So when I print my set, I can call the variable name without the print function. I can also use the print function. So calling it without the print function, it is like this: banana, cherry, apple, orange. Now take a look at this. When we say sets are unordered, look at the way the set was declared. Apple came first, before banana, before orange, before cherry. But if you look at me printing it now, look at it. It's telling me banana, cherry, apple, orange. Are we together? Let me run it again. See what I'm saying? If I run this one now, it's supposed to be giving me, when we print our list and our tuple, it came out the way we write it. The way we ordered it, that's how it came out. But for set, there's no particular order of arrangement. It has its own arrangement. Look at it. Okay? Banana, cherry, apple, orange is different from the apple, banana, orange, and cherry that we declared. So that's why we say sets are unordered. All right? Now, sets do not accept duplicates, which was stated at the beginning of the class. So let's put in some duplicates like we have here. So please, if you are If you are typing, you can type along with me. Sorry for me being too fast. Let me reduce my pace. So you can put down this as fast as possible and then do the next one. So for the duplicates, set does not accept duplicates. All right. So when you are duplicating an item in a set, the program picks the first one it sees and discards the other one that looks like it when it comes to a set. That's why there's no room for duplication. Okay. So let's declare variables. Let me call this my var2. I'll use my var2 as my variable. So I'll put this as my var2. Now, look at it. Apple, banana, orange, cherry, apple, pawpaw, orange. So we have two duplicates. Apple duplicated twice, orange duplicated twice. So let's run this and see the outcome. Watch, the print function is included in this code block. So let's run it. And when we run it, look at our output. We declared 7 items, but we're only getting 5. Because out of the 5, 2 are orange, 2 are duplicates, 2 orange, 2 apple are duplicates. But it picked the first one, saved it, picked the second one, saved it, and disregarded the duplicates. Okay, that's why you are seeing it. And don't forget, sets are unordered. So pawpaw that is here is coming as the first, before orange, before apple, before banana, before cherry. So there's no particular order of arrangement in sets. Okay, the way mine is might not be the same way yours will be. Okay, but for list and tuple, the same way we write it is the same way we put it there. That's how it's going to come out. All right, so no duplicates are allowed in sets. Now, next, you can add new items in a set. For a tuple, you cannot modify it, but you can modify a set. Now, for a list and tuple, use the append, the dot append. But for a set, append does not work. But dot add is rather used. Dot add is a method. Look at it. It's rather used, not append. Okay. So dot add is used to add. I believe you all can still hear me. Please indicate you can hear me. All right, thank you very much. All right, let's write on. So dot add is used to include a new item inside an existing set. So when you run this, however, my var1 dot add grep. Now I'm using var1 here, so sorry, let me use var2. So that we are proceeding. Let me use var2. My var2 dot add grep. Now we don't have grep here, so let me run it. My var2 dot add grep print var2. My var2. So I'm adding grape to this one. I'm adding grape this. Now, this one is purple, orange, apple, banana, cherry. So I'm adding grape to it to increase the value. All right. So adding grape to it. Now look at where grape came out, the beginning. Okay. Grape came at what? The beginning. All right. So there's no order of arrangement. So even if you're adding multiple items, it came at the beginning. Now you can use dot add to add singular items. Okay, just like the way append in list does not add 2 items at once, add 2 dot add does not include 2 items at once. So it's a singular item, one after the other. All right. So if you want to be putting more items, you have to repeat this line of code multiple times with different values inside the bracket. All right. So grape is added at the beginning. It can be added at the middle for you. It can be added at the end or anywhere. All right, guys. Now, the next thing to note is that you can use the update, the dot update, to also include more items. Now, in the list and in the list, we use the dot extend. Set does not have a method or attribute extend. Rather, it has update. Right? It has update. So, if you want to extend a set, you want to extend a set, all right, you can extend it with another different kind of values. Now, this you are seeing now is declared as a tuple. I'm supposed to ask you guys that question, but I've answered it. This you are saying is declared as a tuple. All right. I can even declare it as a list and use it to update too. It will still work. So I created my var2, which is a new variable, and I created var2, which is a new variable, and I said update. Let me use this as var2 so that we won't be going back. Update my var2 with watermelon and lemon. Now note my var2 only has grape, pawpaw, orange, apple, banana, cherry. I'm updating it with watermelon and lemon. I want to put watermelon and lemon together at once. So I'm going to print my var2. Note this code, please. Dot update. Okay. I'm going to print it and run it. Now, as you can see, it ran, but it did not turn this to tuple. It did not include the bracket here. It removed it from the bracket. In list or in tuple, if you are adding a list to a tuple, it comes with the square bracket. If you're adding a tuple to a list, it comes with the round bracket. But here, it does not regard all those ones. It removes them and takes the item and put it in a set. All right. So that's why you have grape, pawpaw, orange, apple, lemon, banana, cherry, watermelon. As you can see, lemon, it did not come at the end. Rather, it's at in between the list. While watermelon was at the end. So there is no order of arrangement. That's why we say sets are ordered. All right. So we've increased the value of our sets by about 2. All right. So also we can also check the length of our set. The same way we checked for the length for tuple and list, we can also do that by calling the len function, len function. So we can say length is equals to len. I like assigning to variables, like you should know by now. So I like assigning, and the length returns the number of items in a container. Returns the number of items in a container in a variable. So my variable is a set, so it's going to return the length of my set. So when I do this, this is my var1. So let me run this. Now, don't forget that my var1 was created at the beginning of the class, which was 5. Now, let me put my var2 inside the program to get the length. Now, you see my var2 is now a length of 8. 1, 2, 3, 4, 5, 6, 7, and 8. Watermelon being the last. So that's why we have this. All right, guys. I hope we are following with the class. This indicates so that I know I have people with me. Are we together, guys? All right. Let me continue the class. Thank you very much for the response. Now, in sets, there's what we call membership. All right. Now, membership simply checks for a value within a set to know if it is part of a set, which is the next line of code here. Now, how do you check for that kind of membership? You call the in function in a print statement. Look at it. You call the in function in a print statement. So print apple in my var1. Print apple in my var1. Okay, guys. Now, when I run this, it tells me true. Now, because we are checking for membership, we are texting, doing logical analysis. We are asking the program a question. Okay. That's why we use the in function. So you are telling it, is apple in my set variable 1? You can also check for variable 2, no problem. Is apple in my set variable 1? If it is there, tell me yes or no. That is what we're simply telling the program to do by using apple in variable what? 2. Tells me what? True. Now let me put in something that is not there. Let me use mango. Is mango in variable 2? It tells me false. That's simply what we are telling, giving instruction to do. Print mango in variable 2. Check if there's mango in it. Or is there mango in my variable 2? Yes or no. False means no, true means yes. So it gives me a false because mango was not declared anywhere in the variable. But if we check for something now like orange in variable 2 or watermelon, let me use lemon. Is lemon in variable 2? You run it, gives you true. So this is how you check for membership in any given set. All right, in any given set. Okay, so we can also do the dot copy in a set. We can also copy my var. We can copy them. So I'm going to do my var, new var equals to my var2 dot copy. So I'm copying all the items in my var2. I'm duplicating it in a new variable. So this new var becomes a new set. All right, becomes a new set. So when I run this, it's gonna work. Then if I come and print call new var, let me call new var. Call new var. It gives me the items like this. All right, these are all my items in my set. Okay, so let me include it in print so that it comes straight line. Print new var. Sorry. Okay, so grape, pawpaw, orange, lemon, apple, watermelon, banana, cherry, just like we have in my var 2 up here. Look at it. Same thing. All right. Now, but unfortunately, look at it. On all that, in my new in my var 2, look at it. It is grape, pawpaw, orange, apple, lemon, banana, cherry, watermelon. But in my var 2, it is grape, pawpaw, orange, lemon, apple, watermelon. So it changed it, banana, cherry at the end. That's why we say set and order. So it's not, you cannot do something in this set because it's unordered. You cannot index it. All right, because it's unordered, you cannot perform indexing like you can perform in tuple and a set. Note that. All right. So if you say you want to check for indexing, all right, let's see. Let's check for an index in a set. So I'll go indexing in set. Does not work. So let's try it. Let's say call my var2, watch, new var my var2. I'm going to get an error because why? Set object is not scriptable. Indexing does not work because values change all the time. So it does not know which value you want to get. That's why indexing does not work in set. I hope that is clear. So I'm going to put this and leave it there. All right. So you can remove an element from a set. You can remove an element from a set by using the dot remove. All right. The dot remove. You can use that to remove an element. Now in the list, we use dot delete, but here we use the dot remove. All right. So Python has different methods and functions which are specifically made for a particular kind of structure you are working with. So you can use the dot remove to remove grape. So when you print, sorry, let me use my var2. So when you print var, okay, I'm printing var1, so grape is there. So let me remove something from var2. Let me remove, what should I remove now? Okay, let me remove apple from var2. Let me remove apple. Now, okay, let me remove from, okay, let me remove from var2. Look at my var2 here. var2, apple. I want to remove apple from here. Now, var2 has grape, purple, orange, apple, lemon, banana, cherry, and watermelon. So let me remove apple here. So I want to remove apple. I'll run it. So I've removed apple. So let me print it. Now you see that from 8 items, we now have 7 items. All right. So apple is gone from our set. Okay. Apple is gone from our set. So also we can pop. All right. We can pop. The same way we pop in list, we can pop in set. Now, when you pop in list, when you pop, it pops off the last item in the list. But in set, it pops from the beginning. All right. So different methods operate differently in different kinds of data structure. The pop removes from the end here. And I told you guys, if you want to specify what you want to remove from your list, use the delete. But in set, the pop removes from the beginning. That's why when I run it, you are seeing grape is coming out. You can even copy it and save it somewhere. Okay, like we normally like doing. All right, you can save. But if you want to specify what you want to remove from your set, use the dot remove. All right, use the dot remove. So if I print my var2, you see that grape is no longer there. So I'll print my var2. You see that grape is gone. Grape is gone. So also you can use the dot discard. You can use the dot discard. It is strictly for sets. All right. Discard does not work for list or tuple. It's strictly for sets. It has the same method, just like the pop, the remove, and the delete you have is the same thing. Give me some minutes, guys. I'll be back. All right, I'm back, guys. So let's proceed. So, discard. Let's discard banana in var2. Let's discard banana in var2. You see it's run. So when you print var2, banana is gone. So banana has left the sets. Okay. So that's how you do that. So we've talked about remove and discard. Let me delete this. All right. Now, are we together? Now, when you are using discard, this is the difference between discard and remove. When you are removing an item that is not on your list, you're going to get an error. Okay. When you are removing an item that is not on your list, you're going to get an error. Look at it. Let's remove mango. You're going to get an error. All right. It will give you an error. All right. But in order for you not to get this error, they introduce what we call discard. So if you are trying to remove something that does not exist in your set and you use discard, you will not get any error. All right. So watch. Let me remove mango again using discard. So I'm going to remove mango. I'm going to remove mango. I'm going to run it. As you can see, there's no error that popped up, but it ran, but it didn't give us error. Though mango is not on our var2. It's not in my var2. But when you're using the remove, you have an error, which we have here. Key error, mango is not there. Okay? That's why you have this error. So rather than using that, if you don't want an error to disrupt your flow of code, use discard. That's why we have this. So in order to remove your everything on your list, use my var.clear. It wipes off everything on your set. So even if you go and print my var, let me print it from this point. You see, oh sorry, I'm clearing var1. Let me call my var1 here. Sorry guys, I went to call the wrong thing. So let me call my var1. So if I'm printing my var1, even if I'm printing my var1 here, there's nothing to print. Look at it, set is empty. So even if I clear my var2 here now, watch, I want to clear var2. I'll run it. To run. var2 has been cleared. So if I come here and print it now, var2, watch. It show me set empty. Okay. So that's how you clear and remove everything on your set. Now, in mathematics, we were taught sets and subsets and some other methods in set. Okay. Also in programming, we have sets and subsets. All right. Now, var1 is a set. Okay. var2 is a set. All right. But because the elements in var2 are present in var1, var2 is a subset of var1. Because the elements in var2 are present in var1, var2 is a subset of var1. All right. var2 is a subset of var1. Now, how do you move ahead to check if one set is a subset of another set? You use that by using what we call the dot is subset method. Is subset method is what is used to check if one set is a subset of another set. So created a variable called is subset, is underscore subset, and I call my var2. I'm telling the computer that check if var2 is a subset of var1. Then I'm using my print to include a subset. So when I run this, my answer will be, oh, sorry, I didn't run this. Oh, pardon me, guys. I didn't run this. So when I run this back, my answer will be what? True. Because we are giving it a logical condition to check. Check if var2 is a subset of var1 with the is subset method. Okay. So when you run it, you get what? True. I just use this one now is like a statement. Just print the statement for me and put my answer. So I have true. Now that you check if it's a subset of this. Now, the same way we have subsets, we have superset too. We were taught in mathematics, all right? We have subsets, we have supersets. A subset is like the child of a parent, while a superset is like the parent of a child, all right? Now, to check if a set is a superset, use the is superset method. You can see Python is just plain English. So the is subset is used to check for subset, while the is superset is used to check for superset. So I declared another variable called a superset, and I said var1, check if var1 is a superset of var2. Now look at the arrangement, they are not the same because I'm checking one against the other. So I need to specify my order of arrangement of my code. If I put var2 here, I put var1 here, it will tell me false. That's why here also var1 is the first, var2 is the second. If I put var2 here and I put var1 here, I will get false. But I'm not going to do that. Let's continue. So it's superset. I'll run this. So my answer will come out as true. All right. So if I come here and go and put var2, arrangement matters in programming. Sorry, var2. And I come here and I put var1. If I run it, I'm going to get false. I'll get false. All right. So arrangement matters a lot, guys. Arrangement matters a lot. So you must be sure that you arrange your program very, very well. All right. So the subset method is to check for subset, while this is superset is to check for superset. All right. And your arrangement matters a lot. I won't repeat that again. So let me reverse back to the way my program is. I'll run this back so I get it true. Okay. So also, we were taught union of a set, intersection of a set, difference of a set in mathematics. So also we have it in programming. All right. So moving forward, let's check for the union. Now, how do you union? You combine. That's the sense of union. Combine two sets together, add them together, merge them to become one. Okay. Now, to you do the set union, you use the method called dot union here. Dot union. So don't forget your order of arrangement matters a lot. So we declared a variable. Let me use this as set. Let me call this set one. This is set one, and this is set two. This is set one. This is set two. So I said set one is equals to apple, orange, banana, cherry, 4, and apple. Why set two is 7, 8, watermelon, banana, lemon, grape, orange. Now, there's a reason why duplicates are on this place. So you should know what will happen when we union it. All right. So when I run this, it's going to print set 3. As you can see, it printed something for us. Okay. Printed something for us. Now, don't forget, set 1 is active, set 2 is active, set 3 is also active. Now, what we are checking against is what is not present in both sets. Okay, that's what we have now. That's what we have. Okay, what is not present in both sets? Can you guys still hear me? Please confirm you can hear me and see my screen. Can you see my screen? Okay, one person can see, another person cannot see. If you can't see my screen, please, 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 please refresh your network. Please refresh your network. Thank you. No, somebody will ask me a question, you know. Ah, so why am I seeing 1, 2, 3, 4, 5, 6, 7? Don't worry, I won't answer that question. I won't answer the question. Now look at it. So whatever we are unioning now, combining these two sets, you are seeing apple, orange, banana, cherry, 4 apple, 7, 8 watermelon, banana, lemon, grape, orange. Now unioning them together, combining them together to form one set. You are going, the duplicate will be removed, and don't forget set is on order, so anyone can come. That's why set 3 is not a combination of set 2 and set 1. So it's checking everything, picking them. If the duplicate is in this set 1, this duplicate is set 2. If it is here, it will not pick the duplicate. It will pick only one and leave one. That's why we have only one orange. So it's checking what is duplicated, what is similar there. It's checking it. The one that is similar, it takes one, leave the other one. The one that is not similar, it adds it. That's why we have grape, we have 4, we have orange. Don't forget 2 oranges are here. We have 7. We have apple. Don't forget 1 apple. Lemon is 1. Watermelon is 1. Banana is 2. But it picked only the first banana and left the second banana. Or maybe it picked even the second one and left the first one. We won't know. But it should sure pick one and leave the other. Then it added cherry, which is there in another set. All right. So that's why we have our union set. Also, we have set intersection. Set intersection. So I'm going to take this as I think this is the same thing. So I'm going to comment this is the same thing, or I will just remove it. So I'll remove it. Let me remove it. I don't need it. Okay, so this is set 2, set 1, and set 2. So I'll call this my set 3, set 4, sorry. I've already had set 3, so this is my set 4. And this will be my set 4. Now, for the union had remove the duplicates from either set and combines them together. But it's at intersection. Let's run it. Intersection looks through the program. It looks through the program and picks only what is present in both. That's what we mean by intersection. You know, when you draw your Venn diagram, you shade the one that is, when you shade the part, you say, okay, this part is the union, this part is the intersection, this one is the difference. Same we have apple, orange, banana, cherry, 4 apple, then watermelon, banana, lemon, grape, orange. Looking at our apple, we only have banana and orange. Why? Because banana is in set 1 and is in set 2. Orange is in set 1 and is in set 2. So that is the intersection. They are sharing the same 2 similar items. So intersection only brings those similar items for us. Your mathematics Venn diagram explains this. Also, we can check for the set difference. Since the union adds, the set intersection gives us what is similar. The set difference only brings out what is not similar. The two things they don't have in common, the things they don't have in common, that's what difference brings. So we have, I'll remove this. I don't need this because I'm working with my set. So I'm using set 5 here to make my code look more good. I'm using set 6. So I interchanged the whole program. So you see the 2 outputs. So this is set 5. This is set 6. Now, to do this, I'm checking. First of all, I'm checking set 1 against set 2. So I'm telling it that take set 1 and check the difference in set 2. Give me an output. Then the next one I'm saying take set 2 and check the difference with set 1. So whatever you choose first determines the outcome. All right. So when I run this, or let's say I run this, let me delete this. So if I run this, watch the two outputs. Are you saying the output is different because it's checking one against the other? The first one, because we are saying set 1, we are picking set 1, and we are telling it that use set 1 to check set 2. Give me only the difference of set 1, which is this. That's why we have apple, which is not here. We have 4, which is not here. And we have what? Cherry, which is not here. That's why you have this output, apple 4 cherry. Because why? It's only checking for the first set. It's using the second set to compare and only bring out the values of the first set. That's why your order of arrangement of your code matters a lot. So the second one I did, set 6, simply says take set 2 and use set 1 to check the difference. But you're only printing the, well, it's only going to print you the output of set 2, not combined. All right, this is the difference between our programming difference and that of our mathematics. In mathematics, we are going to write out all the difference we have. So, but here we are only picking one against the other, depending on how you arrange your query, how you arrange your program. So for the first set 5 says take set 1, use set 2 to check the difference and give me the difference in set 1 that is not in set 2. That's why we have this. Then I said, sorry, I'm going to put this as set 5. And I'll use this as set 6, sorry. Let's run it again. Then I said, take set 2, use set 1 to check the difference, but give me the items from set 2 that are not in set 1. That's how you have this place, these two answers. There's a reason I did that, so that you guys will understand the principle of difference. Okay. Now we also have what we call symmetric difference. We also have what we call symmetric difference. So this is the same thing we're working it. So I think I have to remove this. Let me just remove this. Now, symmetric difference, this is set 7. And I'll use set 1 to do symmetric difference. Now, the difference, normal difference we did gave us the values for one set against the other set. Then when we swapped it, it gave us the values for this set against the one that's in the bracket. But symmetric difference works differently. So I'm going to use set 1 here. I'm going to use set 2 here. Now, symmetric difference works differently. Works differently by what? Giving us the difference combined. All right, now this one looks like our mathematics Venn diagram because we picked the combined one and used it to form another set. That's what you're seeing here now. But for here, it says take only the difference from one set, not the other one. But here, the symmetric difference takes the difference, it takes what is common between them, throws it away, and what is uncommon combines them and forms a new set. That's why we're having the grape, which is in set 6, the 4, which is in set 5, this 7, which is in set 6, combined together. Don't forget, I'm checking set 1 against set 2 though. So it's the same attribute. So grape, which is in set 1, yes, grape, which is in set 2, is picked, while the 4, which is in set 1, is picked, and everything are combined to form symmetric difference. Okay, guys, that is how set works. That's how set works. So next, let's take a few questions. Let's take a few questions, and then we move on to the next data structure, with the dictionary. So I'm going to set a few questions. So if you have a question, raise up your hand as usual, and you have the floor to speak. Please limit your questions, and if your question is taking us to the beginning of the class, sorry, I won't attend to you. Thank you. All right, if you have questions, raise your hands, and I'll pick. If there are not questions, I can move on. All right, I take it there's no questions. So let's move on to the next part of the last part of our data structure, which is dictionary, which will be dictionary. Thank you. All right, so dictionary is the same as a set. It uses the same bracket, like we explained. But the difference with dictionary is that it is ordered and it comes with a key and value pair. Set comes singular, singular values, but dictionary comes in pairs, a key and a value, a key and a value, and it's both assigned. That's why I have this colon in between them. There's a colon in between the key and the value. The first item is a key, while the second item is the value before a comma. All right, so that's how it is specified. Now, um, this variable one we declare, this is a set. All right, this is a set. Okay, this is a set. This one you see is a dictionary, and this is a dictionary. All right. Now, in for those who are creating web design and all, they work with what we call JSON files. All right. What we call JSON files. JSON files is used to accept inputs or edit inputs of some particular items or maybe individuals. Now, a JSON file is structured like this. This is how it's structured. You have a curly brace, which shows the dictionary. Now, as you can see, this one I highlighted is this. That's why you see the color codes are different, blue to blue. Then the first green is covered here, separated by a comma. Then the second one is covered there, separated by a comma. All these info here are in what we call outer. This is student info, which is a dictionary, which has these items: name, which is the key; OSAS, which is the value; age, which is the key; 15 as the value; height, which is the key; 4.5 as the value; weight, which is the key; and 50 as the value, enclosed. And this is also another one showing school info, school name as the key, pattern in pidgin as the value, course scores are the key, then a list as the value, all covered in what we call outer. So this is how a JSON file is scripted. All right. So when you print this, oh sorry, I did not run this. Sorry guys, let me run this. If I didn't run it, I'm gonna have an error. Okay, so let me run this. So when you run this, look at it. It's arranged like this. Student name, student info name, OSAS belief, with an age of 15, a height of 4.5, a weight of 50. School info as a school name, title and PG, and these are scores. Now, this is a dictionary collaborating like this. All right, this is a dictionary. Okay, but this is a JSON file. This is the way it's scripted JSON file. All right, but we can also script a dictionary like this. All right. Now, a dictionary comes with a key and a value pair separated by comma. So, an info here we have is a variable which houses the dictionary name as the key, Peter as the value, age as the key, 36 as the value, marital status as the key, force as the value, course as the key, data analyst as the value, height as the key, and 5.5 as the value, closed in bracket. So you can do it like this. You can also do it like this as a JSON file, no problem. It's still going to work the same way. So when you run this, it prints info and it comes out straight line like this. Okay, comes out straight line like this. So as you can see this way, calling just info now, it's looking like this. All right, but printing using the print on a straight line, or calling directly prints next line after the comma. So that's what we have here. So as you can see, this is also similar to this. All right. So that's how you do define a dictionary, or you put items in dictionary. Don't forget key and value pair. Now you can index in dictionary. You can index in dictionary, but in list and in tuple, we index by index number. But in dictionary, it does not work with index number. You index by calling the key. You index by calling the key. You index by calling the key. All right. If you don't call the key, you won't get the value. But in tuple and list, you call the index number, you get the value. But here you must call the key. That's why we call dictionary as the baba of all the data structures. It's the top, because every data we have, you are analyzing, every data you have is scripted in a dictionary format. Right? Scripted in dictionary format. So in order for you to access any item in the key, now we have these items. We have info, name, Peter, and the likes. Now, this key are also called columns. Right? They're also called columns. While the Peter, James, and the rest are rows. But the name, the key, name, age, marital status, cause the things before the column, what the values before the column are the keys. They are also known as columns. All right. So if you want to access any value, you must call the key which has that value. So it's less like creating a variable inside a variable inside a variable. That's how it works. So in order for you to get it, just call the dictionary and then call the key. The key will locate the value and bring it out for you. It won't bring the key. So let's print info height. Now, height here is 5.5. So when we print info, we are not going to get height. We are going to get 5.5, right? Because height locates 5.5. So height 5.5 won't be showing here the way it's showing here. It won't be showing like this, but it will just get only the value. All right. So let's say we are getting age. We are getting age here now. Okay, let's say we want to see the age. If you run this, you won't get age as this, but you're going to get the value assigned to age, which is 36. All right. That's why we have 36 here. We don't have age colon 36. We just have just 36. Then you can also modify values in a dictionary. But in order for you to modify these values, you need to locate them by the key. That's why indexing is important in every aspect of data analysis. Indexing is what? Important. Now, let's say we want to change the name from Peter James to John Frank. I want to change the age from 36 to 30. All you have to do is index, call the dictionary. That is the name of your dictionary. It can be a table. So call the name of your dictionary. And then call the key, which is the column name. And then what do you want to change? Assign a new value to it by using the assignment operator, John Frank. So anywhere, anything that is in name before will be replaced with John Frank. And also do same for age. Any value that is in age before will be replaced with what? 30. So when you run this and you print info, John Frank is here, 30 is here. Don't forget it was Peter James and 36 as the age. But modifying it, we had John Frank and 30. You can also change the marital status from false to single. So let's do that because it's showing false. So let's go and put single there. So all I have to do is come and call info. And I put my index bracket and I call marital status. Click it. It's a dictionary key, as you can see. Then I'll assign a value. I'll put string. I'll say single or married, whichever I want to put. So if I run this again, I'm going to change my marital status from false to single. All right. That's how you modify values in a dictionary. You must call the key. Very easy. Then also you can add a new key and value to a dictionary. You can add. Now, how do you add? You assign. Now, I know in the when we are doing list, we did the dot append, the dot update. So at dictionary, you only use the assignment operator. All right. So you say you are simulating the program that on the dictionary info, create a new key called weight and put a new value called 55.5. Don't forget, in list, we did the append, the dot extend. In set, we did the dot update, the dot add. But in dictionary, you don't do those things. All right. You simply call this. If you're working with dictionary, call the dictionary name, specify the new. Now this is a new key. It's not here. We only have height. Weight is a new key, so it's seen this as a new key with a value attached as 55.5. So when you run this and print info, weight will be added at the bottom. As you can see, weight is added. So let me just call info here so that you're going to see it well. Let me just call info and remove the print. So weight is here, all right, 55.5. Look at it. It was not here before from this point, but it has been added here, 55.5. So that's how you put new key and value into the dictionary. If you are putting a new key and there's no value, you will get an error. If you're putting a new value and there's no key, you will get an error. Okay, so you must put it the same way it is being created, key and value pair. That's how it works. So trying to get a value of a key that is not present in the dictionary, this is what we're going to happen. Okay, you get an error, key error. Same way when you're trying to index a number that is not in a list, you get an error. Okay, so if you are trying to get that, you get an error telling you key error CGPA, which is not even present. So you get these errors attached. All right, guys. So let me exit this. Sorry, clear. I hope you guys are following the class. Please react with some thumbs ups or any reaction of your choice, so I know you guys are still with me in the class. All right, so let me drop the attendance now. Sorry, the attendance has been pinned to the group. It's pinned already for those of you who saw it, but I will send it again. So fill your attendance. When the class terminates, attendance closes immediately. Thank you very much. So let's proceed. All right. So trying to get a key that is not present, you get an error, key error. Okay. Now trying to also get values that is not in a dictionary, you're also going to get an error by telling you none. Okay. Info.get. Get is a method to get any item in a dictionary. But rather than it returning your error like the info index key does, it only tells you none. There's nothing like this CGPA in the dictionary. So info.get does that for you by removing the errors. So you can also specify something. Now it told us none because automatically when it doesn't see it, it tells you none. Okay, but you can also specify something. You can also specify something in it. Okay, how do you specify? You put a comma after the item you want to get, after the key. We're calling the key, whatever is in the key. Then you said, if this thing is not found, tell us oops, not in dictionary. This is how you specify it using the print. So if I run print, I'm going to get oops, not in dictionary rather than none. So look at the difference and note them very well. Okay. So if you want to get all the columns, all the keys in the dictionary, you use what we call info.keys, the .keys method. The .keys method gets you all the keys in the dictionary. Okay. So print info.keys. So it's going to tell you the keys in your dictionary underscore keys are name, age, marital status, course, height, and weight. So Pedi, you want to analyze the data and you want to find the columns, you want to know what to view, you use the dot keys to get such information in a dictionary. Okay. Also, you can include it in your for statement. You can also check a key. You said for key in info.keys, if key is equals to marital status, print key. Create a key, a variable called key in info.keys. That means check all the infos of the name, age, marital status, course, height, and weight, assign it to a variable key. Then put a conditional statement telling you that if marital status is a key, is found in variable key, print the key. So when you run this, you're going to get marital status. But if it's not found, you get an error. Okay, tell you none. All right. So that's how to clean this in a first statement. Then you can, same way you can check for keys in the dictionary, you can also check for the values. Now for the keys, you call dot keys method. For the values, you do dot values method. Plain and simple like English. So when we do print info dot values, it gives us all the values of the person. As you can see, it's telling us John Frank, 30, single, data analyst, 5.5, 55.5. From here, we could say, okay, John Frank is the name, 30 is the age, marital status is single, his occupation is data analyst, his height is 5.5, while his weight is 55.5. All right, so same way you can get the keys, you can also get the values in the dictionary. Okay, now to get both the key and the value together, we use what we call the dot items method. These are only what things that you use in dictionary, not in list, not in tuple, not in set, because they don't come in pairs. But in dictionary, they come in pairs. So they get the key and the value of a dictionary together, use the dot items. So when you run this, gives you the items here, gives you the key, and then gives you the name, gives you the key, and gives you the name, till the last one, the key and the value. All right, that's what we get here. So also you can do the dot copy here too, to also copy a dictionary. The dot copy method can work here to copy a dictionary. So when you print info too, it has the same values as your info. So I did a copy here so that I can easily manipulate, remove my info to and leave the info. Now the info is the original dictionary, the info 2 is a duplicate. So I'm working with my duplicate by modifying it by removing and popping. So I want to pop age. Now when you are popping age, when you are popping age, the same way you pop in a list. When you are popping list and set. But when you are popping in dictionary, you specify what you are popping. I know in list you can specify, you can decide not to. When you don't specify, it pops anything. When you specify, it pops. But dictionary, you must specify, otherwise you have an error. So info2.pop age. So when we are popping age, we are not actually leaving the age, but we are removing both the key and value. That's why we are popping age. It pops out both the key and the value because they come in pair. They go in pair. So when you say info2.pop, it pops out 30 for you, as you can see. You can actually assign this. I told you the pop allows you to remove an item and save it somewhere. That's why you're seeing the attribute here. But when you use dot clear, it does not show you any attribute. It only shows you, okay, I've done it. But the pop allows you to pop it off and save it somewhere different so you can get it back. So when you print infos.2, as you can see, you don't have age here again. You only have the name, the marital status, course, height, and weight. There's no age because it pops, it pairs. Now let's print the original file so you see the differences. The original file we copied, nothing changed because we did a copy. So that's why age is still on the original file, but on the copied file, age is not there because we've popped it out. Okay, so that's how the pop works in a dictionary. So you must specify the key you want to pop and it pops it. Now, you can also delete. You can also delete. Sorry, let me remove this. You can also delete. So I'm deleting from info2. I'm using the function delete. Delete what? Course. So let's run this. So after deleting course, it prints out everything. As you can see, course is no longer here. So you can pop, you can delete. As you can see, the difference between the pop is the arrangement. Pop is a method, delete is a function. Don't get it twisted. Okay, same way you apply it in this, same way you apply it here. All right. So the dot clear too clears the dictionary. That's why I say pop allows you to pop and save. Okay. Delete does not allow you to save, but clear allows you to wipe without saving self. Delete and clear wipes without saving. Pop allows you to save even after popping. Keeps it in the memory. So dot clear removes everything in your dictionary. So when you now print your dictionary, it's going to tell you empty. That's why you're seeing the curly braces with nothing inside. For set, it will have a set here, set with a empty curly brace. But this dictionary is just an empty curly brace. Okay. Also, because we have list comprehensions, that is when we did list comprehension, writing blocks of code in a single line. We also have dictionary comprehension too. Okay, this is dictionary comprehension, which we do straight line the way we are doing it. A colon one, we do all this. These are comprehensions. All right, but if you break them down, like bring this one in next line, this is no longer a comprehension. But writing it like this is a comprehension. Okay, call it list comprehension, but for dictionaries, straight line of code. So that's why I have D. We created D as A, B, C, D, E, all having the values 1, 2, 3, 4, 5, respectively. So let's run this and we have that. So we can use the for statement to print the pairs. Now, for the values, for the keys, we call the dot keys, like I told you. For the keys, we call the dot keys. For the values, we call the dot values to get just the values. You can also do it a different way by using the for statement. So for pair, create a variable named called pair. Then take all the items in D. Take all the items in D and print them in pair. So when you run this, you say for pair in D items, print out pair. So it's going to print pair first, print pair second. So no for is a loop. So you understand how it works. First of all, it prints the first one, the key and the value. Then it goes print the second one, print the third one, print the fourth one, print the fifth one. Okay, so that's what it does. Then you can also create new dictionary. Okay, that's why I say list comprehension. You can also create a new dictionary with only pair values. All right. Now, so you can see this is what we are doing now. We are creating a new dictionary with only pair values where the value is larger than 2. So we are also using the for loop to create a dictionary. So we said new dictionary is equals to K to V. Now, this is what we call slicing. It's a form of indexing, but it's slicing. So we are telling it, we are putting the slicer inside the dictionary. So we are telling it, create K from K to V, use K and V to create new items when V is greater than 2. K colon V, as you can see. I know I am saying K colon V. Key colon value. So for key to values in D items, from that, we're using these D items we created here now. These D items, A, B, C, D to E. So we are saying from K to V, using K to V as the key and the value, we are specifying new ones. So K is the key, which can be anything, A, B, C, D. V can be 1 to 3. So because we are using D items. So for K, comma, V in D items, that means anywhere you see K, take the key in D items. Anywhere you see V, take the value. If V is greater than what? 2. So running this is going to give us an output. And when we print it, we're going to see C, D, E. Because of this conditional, if V is greater than 2, create a new dictionary called new dict and take out just the values greater than what? So that's why we have 3, 4, 5. That is C, which is the key, 3, which is the value, and D and E with their values 4 and 5 respectively. Because of this, what? For and if conditional statement. Right? Also, we can perform operations on key value pairs too. All right. So dict2 is a new dictionary, and we say K plus C. Don't forget that C is what? The key in our D dictionary. D. C is the key. So we said K, which is a new variable, plus C. All right. K plus C. Then ratio V times 2. So what we are simply doing here now, we are adding the key to the newly generated one. We are generating a new key. So we are performing operations on it, arithmetic operations. So we are adding this key to this. Then the value of this, we are multiplying it by what? 2 for K, V in D items, if V is greater than 2. So anywhere V is greater than 2 in values, multiply 2 by it, and then bring the key and assign it again to this. Then print dict. So I'm going to let me code this. Don't need this one. So print dict2. So let's run this. Don't forget, in this first one we just did the for loop. We created kv, then we used the kv to loop through the items when v is greater than 2 and create new dictionary. That's why we have C with the value of 3, D and E with the value of 4 respectively. So here now we are doing an arithmetic operation where we are adding the C, which is, don't forget, C is the key in D items. Then 2 V, you are multiplying V. That is, anywhere you see C, pick the value. If it's greater than 2, assign it to V and multiply it by 2. That's what we are tending to do from D items. So we've run it, and let's see our output. We are seeing CC 6, DC 8, EC 10. That's why I said we are adding. Now, when you are adding strings together, you are concatenating, because what we did here now, we said take K. K is what? K is working with these ones. C, D, E. Right? While V is working with 3, 4, 5. So anyway you see K, pick the value for D items, add C to it. That's why we have CC. Anyway you see V, which is the key for C, multiply it by 2. That's why we have 6. 3 times 2, 6. Then he moves to the next one. After when he's done with this first one, it goes to the next one, loops again. Then it goes to the next one and says what? D, which is the K. Add C to it. That's why we have DC. Then it took the value, which is 4, multiplied by 2. That's why we got 8. Then it looped again. It took the key, which is now E, add C to it. That's why C is in string. Add C to it, which is EC. Then take the value for E, which is 5, multiplied by 2, which is 10. That's why we got this double and increased key and value pairs. Also, we can convert data structures. We can convert from list to set to dictionary by specifying if we want to. How do you do this? Now, first of all, we declare the new list called 3345699. So this is a list. So when you print it, it's a list. If you check for the type, check for the type. Sorry, let's check for the type. I'm going to put my bracket. I'm going to check for the type. So you can see this is a list. All right. We created a list of these items. Now, we want to convert this list now to a set. How do you convert? You by calling the function set. Okay, by calling this function set, you convert. So anywhere the program sees set, it means convert whatever is inside the bracket, whichever data structure it is, convert it to a set. That's why we have set in bracket new underscore list. So when you run this, you're going to see this is now a set. So from it being let me remove this, let me take it back to so from it being in square bracket, which is a list, it has turned to curly bracket, which is what set. We can also convert from this list to what a tuple. All right, so let's run it. As you can see, from being a list square bracket, it became a set. Set does not take duplicate. That's why you see only 1 3 and only 1 9, but here it is double. In tuple, it's also doubled. Tuple allows duplicate, so you cannot modify like we know. Okay, so this is a new. Now look at what we did here again. We created a set called fruits: apple, banana, orange, cherry, apple, purple, orange. I want to convert it to other data structures. So I run this. Don't forget, you call the name of what you want to convert it. If you want to convert to list, you call list. If you want to convert to set, you call set. If you want to convert to tuple, you call tuple. If you want to convert to dict, you call dict. That is dictionary. DICT is short for dictionary. So we run the fruits. Now I want to convert this set now to a list. So we are calling the function list and assigning it to a new variable, my list fruit. So when you run this, we're going to get list. Look at it. From fruit set, let me run this fruit. So that's let me print this fruit. Let me print this fruit. So from fruit set, curly brace, it changed to what? Fruit list, square bracket. So this is a list which you can manipulate. So I can also convert this fruit, which is a set that we have here now. I can also convert it to what? A tuple. Same way we converted a list to tuple, you can also convert it. As you can see, purple, orange, apple, banana, cherry. Yes, having apple, banana, cherry, orange, purple as set. But here it's just what? It has changed because we have converted it. Okay? So that's how they convert to tuple, which is the same thing as here. So this is converted to tuple, converted to list, and this. So you can convert a tuple to a set as well. Watch now. I'm converting this tuple now. This tuple, I'm converting it back to what? A set. I call it fruit. So I'll just run this, and you can see it has converted. So when you print fruit, it converted the tuple to what? A set. So from it being a round bracket as a tuple, converted it back to what? A set. So you can also do so on that. So this is the same thing. Convertible to set. Okay, we've done that. So convert to list. Okay, guys. So this will be where we'll stop our learning of data structures. This is the end how to convert. So if you have any similar questions or any question at all pending what we've learned so far today in class, kindly raise your hands and I'm going to pick you shortly in class. Please limit your questions to its bare minimum while we move forward. So let me unmute your mics. Please raise up your hands. I have only limited times. When I'm done, like I said, when I'm done with my question, nobody will tell me, sir, I have a question. I'm not going to answer you. Thank you. So, Ofure, what's your question? Since you're the only one on board, what's the
So,
question?
sir, for the key and the value, there was a part where you were multiplying the key by adding c to the key and
C.
multiplying the
Yes,
value by 2. So,
yes,
and you said it should return if the value is greater than 2. Now,
yeah.
B was 2, and 2 times 2 is 4, which is greater than 2, but it didn't return B. Why?
No, it won't return B because My statement, my instruction was start only when it is greater than 2. That's what I used. Greater than 2, not equal to 2. Look at it. If it is greater than 2, so first of all, it checks before it's added or multiplied. You get me? So
Yes,
it
yes.
checks first because it's going to check with these the items first. That's why I
Okay.
did this in the first place. It's going to check with these the items first. Then, like here now, we check for the d items and we printed the value. Only when it is greater than 2, that's when it's printing the value. 2
Okay.
is not greater than 2, is equal to 2. So greater than 2, it starts from 3. That's why the same thing here, it is going to start from where it is 3, where the value is 3. So it's going to
Okay.
do all this operation on the key and also on the value. Is that clear?
Okay. Yes, sir. Thank you.
All right, you're welcome. Mr. Francis, your answer up. What's your question?
Okay. My question is, you were assigning, sorry, when you were adding values assigned to a
Yes.
variable in a tuple, you were adding them to a set. I'm just asking if you can do the same with lists. That's if a set of that's a list of value and a list, we can add them
Yes.
to a set.
Yes, you can add. Let me go back. Look at this. Like I said, when you're adding a set, like here now, I added a tuple. When you declare a tuple is a round bracket. Let me locate where I did the addition. We have to go back to where I did the addition. I think that's far back. Okay, yeah, this is it. Now look at it. Look at it. Yeah, this is a tuple. Okay, this is a tuple, right? This is a tuple. But is a tuple. It has the value watermelon and lemon. Now, when you update it, listen. When you update this to the set, it does not see this as a tuple. It removes the tuple and converts everything to a set when it enters the set. So also, if this is a list, I make this a list. When it's adding it, it does not include the square bracket. It only takes the values and makes it a set. Because I'm updating with an extension of a list or an extension of a tuple. All right. So you can also, the same way you did it in tuple, by creating a tuple and updating it, you can also update with a list. Even your dictionary, you can do that. You can put new items in dictionary, and also from list you can put the dictionary, but you must specify the key and value pair. These ones now, set takes only values, but dictionary takes key and value pair. So when you are assigning, like we did here now, I have to go and look for that place where we assigned. Yes, like where we created a new. Yes, this one is to modify, where we created a new value. Weight, when we created weight. Okay, yes, where we created weight, now as you can see, this is a new key, this is a new value. So if you want to put a tuple here now, all you have to do is specify the key, then put the name of your tuple, the variable name. Put the variable name here. So all the values there, it will be assigned as one to the key. That's what I mean if you want to assign it in very dictionary. But in set, you can just assign directly by using that update. But in dictionary, you must put a key, because if you're putting that tuple now, it won't be able to add it because it tell you no pair. If you're putting a key without a value, you have error, no pair. If you're putting a value without a key, you still have error. So you must specify what you are doing when you're working with it. I hope that has
Okay.
answered your question.
Yes, yes. Thank you very much.
All right. So I think that ends today's class. Since there are no questions again. So thank you guys for joining in. And by next class, we are going to be talking on functions and methods. So I know some of you might be confused on, oh, this method you're using, how it came about, where it is it gotten from. So in our next class, we are going to be teaching you guys built-in functions and methods from the Python library. Okay, so please don't forget, take your attendance very very, very seriously. Let me post it again one last time. And by 10 o'clock, I stop receiving responses on this. Thank you very much, guys, and do have a good night.